rotation, and then we had expanded our definitions of sine, cosine, and tangent so that they would be in terms of coordinates of a point on the terminal side of an angle rather than, stop talking please, rather than defining them as side lengths in a right triangle. So let's start by finding cosine of 150. So this is 2, 4 continued. Okay, 2, 4 continued. So what I'm going to do first is I'm going to draw a picture of where 150 degrees is. So my initial side always lies on the positive x-axis. And then I'm going to go 90 degrees, and then like 60 degrees more. And here is my 150 degree angle. Everybody okay with that? I'm going to drop a vertical down to the x-axis. I always draw my vertical back down to the x-axis to make my right triangle. Now this right triangle is a special right triangle. What is this angle here? 30 degrees, because 150 plus 30 more should give me 180, which is a straight line. Everybody agree with that? This angle over here is 60, and I know the side lengths of a 30, 60, 90 triangle are x, x square root 3, and 2x. So cosine here is going to be adjacent over hypotenuse. Or square root 3 over 2. Oops. But there is something wrong with this. We did make a little mistake here. Does anybody see what the mistake is? Which side of the x-axis is this on? The negative side. So the negative part, or the part that's drawn on the negative part of the x-axis, should be negative. So it's really negative square root 3 over 2. Does everybody catch that? Just again, what we're saying here is this is the negative side of the x-axis. So this side of our triangle that is on the negative part of the x-axis should be negative. The hypotenuse is always positive. But the 2x, or the x part, is on the positive part of the y-axis, right? So it should stay positive. In this case, it is just the x component. Because what we're saying here is this is the point, negative x square root 3, comma, x. Which makes sense when we plot that point, that we've gone negative over, we've gone to the left, and then up. So the x-coordinate is negative, but the y-coordinate should be positive. Okay? So, the question I'm going to ask then is, can we tell when the trig ratio is positive or negative? Absolutely. So let's draw our xy axis. In the first quadrant, the x-coordinate is positive and the y-coordinate is positive, correct? In the second quadrant, the x-coordinate's negative, but the y-coordinate's positive. In the third quadrant, the x-coordinate's negative and the y-coordinate's negative. And in the fourth quadrant, the x-coordinate's positive, but the y-coordinate's negative. So remember that sine is y over r, cosine is x over r, and tangent is y over x. R, we know, is a length still. It's still like the length, the distance from the origin to our point. R is always positive still. The x and y's can be positive or negative depending on where they lie on the xy axis. In the first quadrant, though, y over r is positive over positive. X over r is positive over positive. Y over x is positive over positive. So all our trig ratios are positive in the first quadrant. So I'm going to write the word A for all. Okay with that? In the second quadrant, sine is positive over positive. Cosine is negative over positive, so cosine is negative. Tangent is negative over positive. I'm sorry, positive over negative, which is negative. So cosine and tangent are negative. Sine is the only one that's positive in the second quadrant. Yes?
Wait, how do you know that the r is, so that's the square root, or x squared plus y squared, the square root of it?
So r is a length. It's that distance from the point to the origin, so it's always a positive number.
Oh.
Okay with that? If I look at quadrant 3, here x is negative and y is negative. So I have negative over positive, that's negative. Negative over positive, that's negative. Negative over negative, that's positive. So tangent is the only one that's positive in the third quadrant. And then if I move to the fourth quadrant, x is positive but y is negative. So I have negative over positive, that's negative. Positive over positive, that's positive. And then negative over positive, that's negative. So the acronym that we'll remember to tell us which one is positive is all silly turtles crawl. So all silly turtles crawl. In quadrant, so what we've written are where things are positive. So in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. So as a result, cosine and tangent are negative. In the third quadrant, only tangent is positive, so sine and cosine would be negative. In the fourth quadrant, only cosine is positive, so sine and tangent would be negative. Okay with that, David? Okay. All right. No, this is a beautiful thing. I will provide a copy copy of the unit circle on every test that you take in this course. Now, if I am you, I basically have this memorized because you use it so much and you'll waste a lot of time going back and monkeying around with it if you don't have it memorized, that leave you very little margin for error when actually taking a test. So this is something that I basically want to be able to either repeat the construction of or basically have memorized anyways. But I would give you a copy of this on every test that we would take here. The quiz I will not say the same. There may be a quiz where I ask you to do something involving the unit circle. It does say centered. So a unit circle is a circle centered at the origin with a radius of 1. And what we're going to do is we're going to complete this unit circle using the values of, or the angles who we can calculate the exact values for without using our calculator. There are 16 of these angles. That's a little too big. Boy, does that circle look really lumpy to you guys? Oh, good. Huh? That's not straight. One moment. Give you the blank and you'll have the class notes. Like you can just watch what we're doing and participate. I'll post a blank one of these if you want one. And you'll have the class notes in the class video if you want to go back and fill it in later. If you're like, this is just too much artwork for me. Like, I get it. I would just sit and watch if I were you. Okay? So, my first angle that I'm going to be concerned with is here. That is a 0-degree angle. Or what other angle could you call this other than 0? 360, right? In terms of radians, what is 0 degrees in radians? Still 0. 2 pi isn't wrong. That's is not wrong because 2 pi is still the same as 360. Can you guys just let me talk? Thank you. So this point here on a circle with radius 1 is at what coordinate? Well, that would be the origin. You mean 1, 0?
Yeah, that's right.
Okay. Let's skip over to here. This is 90 degrees, correct? In terms of pi, that is pi over 2. What is the point there? 0, 1. Let's skip down to here. This is 180 degrees, or just pi. What is the coordinate here? -1, 0. And we'll skip down to here. This is what degrees? 270, or in terms of radians, 3 pi over 2. And what is this point? 0, -1. 270. Multiples of 90, right? 9, 18, 27, 90, 180, 270, right? Everybody's okay with that? All right. So the angles that we can find out exactly are 30, 45, and 60, or their multiples thereof. So the first one that happens is 30 degrees, and then 45 degrees, and then 60 degrees. Everybody's okay with that? What are the next ones? Then we go 120, 135, and 150. Everybody agree with that? And then over here we have 210, 225, and 240. And then we have 300, 315, and 330. Everybody okay with how I filled this in? In terms of radians, 30 is pi over 6, 45 is pi over 4, and 60 is pi over 3. 120 is 2 pi over 3. 135 is 3 pi over 4. And 150 is 5 pi over 6. 210 is 7 pi over 6. 225 is 5 pi over 4. And then 240 is, well, that's 5 pi over 3, I think. Four pi over 3. Thank you, the person that tried to tell me 4 pi. Ann, was that you? Okay. All right. Continuing on. We have here then, let's see, so that's 6 over 6. That is 9 over 6. So this is 5 pi over 3. This will be 7 pi over 4. Yep. And then this last one will be 11 pi over 6. Okay. In a 45, 45, 90 triangle, sine of 45 is 1 over the square root of 2, and cosine is also 1 over the square root of 2. But we usually rationalize our denominators and write that as like square root of 2 over the square root of 2. Everybody okay there? What's up, Ann? Oh, yeah, sorry. In the second quadrant, cosine is negative, so the x-coordinate should be negative. In the third quadrant, both the x and the y coordinates are negative. And in the fourth quadrant, just the x-coordinate is negative. I meant y-coordinate. Goodness gracious. For 30 degrees, cosine is x square root 3 over 2x, or just square root 3 over 2. And sine is x over 2x, or just 1/2. And 60 degrees, cosine is 1/2, and sine is square root 3 over 2. So, translating to the third quadrant, this one is negative square root 3 over 2 and 1/2, and then negative 1/2 square root 3 over 2. This one should match here, so this one should be negative square root 3 over 2, negative 1/2. And this one should be negative 1/2, negative square root 3 over 2. And this one should be negative 1/2, positive square root 3 over 2. And this one should be negative square root 3 over 2, positive 1/2. So again, what we did is we filled in these values for sine and cosine. Those become the x and y coordinates on my unit circle. And I used what I know about my right triangles, my special right triangles, and then where sine and cosine are positive and negative in the quadrant to fill in all the rest of my values here. So for example, if I wanted, say, tangent of 150, I'd go to 150, and then use the fact that tangent is equal to y over x to say tangent is 1/2 over negative square root 3 over 2, which simplifies down to negative 1 over the square root of 3, or negative square root 3 over 3. What's up?
I just said I thought this chapter was supposed to be easy. But why?
This chapter is supposed to be easy. Jacqueline. 270 is 3 pi over 2. So, the unit circle is all well and good, right? If I want, say, cosecant of, say, 225, if you don't want to mess around with the unit circle, you can do this just like we did on the previous example. So we can start by drawing in our 225 degree angle. So 90, 180, and then 45 more makes that 225. I'll then create my right triangle by drawing back to the x-axis. And then I'm worried about what this angle measure is. What does that angle measure have to be? the one that I've drawn the line to? Has to be 45, right? It has to be 225 minus 180. Right? It's the whole thing minus that first line. Everybody agree with that? That means that this one is 45 degrees also, and what we have is a 45, 45, 90 triangle. So if I were to label this, this side would be negative x, this side would be negative x, and this side would be x square root 2. So I know that cosecant is the reciprocal of which one? Sine, cosine, or tangent? Sine. Sine. Remember, no cos go together. So cosecant shouldn't go with cotangent or cosine. So this is the same thing as 1 over sine of 225, right? And sine is opposite over hypotenuse, which is just turns into negative square root 2. Is there a question how we went from here to here?
Yes.
Okay. Please ask then. Please ask. Okay. Okay. So first thing I'm going to do is I'm going to think about this as the multiplication of two fractions. Everybody okay with that? Now I can reduce, and I'm left with negative square root 2. Is everybody okay with that now? So what I'm showing you is that the unit circle is nothing more than our special right triangles condensed into one location. That's all it is. It's just using the special right triangles for 30, 60, 90 and 45, 45, 90 and rewriting those in terms of points on the unit circle. So that's all we're doing is just taking that same information. So if you know your 30, 60, 90 right triangles and you can draw your angle in the XY axis, you can recreate the unit circle anytime you want, for any location you want, and it's not a huge, huge deal. Okay? So all that is, it was a lot of stuff written there, and I went through and wrote the values in really quick, because again, like, I haven't memorized, so I don't really need to do it, but you even saw me talking to myself and reasoning out, like, which one goes where, because I don't really have it memorized. I just know the values for the special 30, 60, 90, 45, 45, 90 triangle situations, and I know where they go. I don't really have the specific locations memorized on the unit circle per se. You know what I mean? So it's one of those where it's like understanding how you make it is easier to me than memorizing everything on there, which is what I kind of do. Yes, of course. To here? Okay. All right. Andrew, you good? All right. So, what if we ask you to what if I ask you to find the value of sine theta? If cosine theta is 5/7, but cotangent theta is negative. So the way we want to do this is I know cosine is positive at two locations. It's positive here in the first quadrant, or it's positive here in the second quadrant. I know cotangent is negative the same place tangent is negative. Oops. I know in the fourth quadrant sine and tangent are negative, so I know I must be talking about this angle theta. So what that tells me then is my hypotenuse is 7, my x side is 5, but my y side is negative square root of 7 squared minus 5 squared, just using the Pythagorean theorem there. 49 minus 25 is 24, which is 2 square root 6. So I can say then that sine theta is negative 2 square root 6 over 7. That's it. I don't think this class meets tomorrow, right? But we can do more the next time. Just FYI, that this is the last section in this chapter. So we are, next time we meet, I am going to have some practice stuff for us to do in class. I'll also post the review between now and then. And we'll kind of see how much we get through. We might need 2 days still. But we'll have it. Yeah, we'll talk more next time.